Hello there, my mate Vince here, and this is a first on the channel, a Nintendo 64, N64, a console that I never owned. Now, this one was left for me when I went to visit my friend in Bristol. This is Rob's N64, and he's a friend of a friend. So I was down there visiting my friend John, and they work in the same office. So basically, I plugged this one in and it's got no power. I told him to leave me the power supply, game and everything, because the only thing I've got N64 related is a controller. Now, if you have a look at that, you can already see that that's very dodgy there. So there should be a little cover that goes over that. So I'm gonna have to sort that out if we can get it working. So first things first, let's check it's not the fuse. Also 13 amp fuse. That's going to be too much for this. This would be, I'm sure, a 3 amp fuse would be absolutely fine here. But again, we can worry about that later. Okay, so you can hear the beep, so the fuse is okay. Now, when I plug it in, I've connected up to the TV, it doesn't do anything. And also, obviously I'm keeping my fingers well away from that fuse. When I turn it on, there's nothing happening here. You see there's no light on here. But I tried tuning it into the TV as well, and nothing came on, just in case the light's gone. So you can see there's nothing happening. So first things first, we need to see, is it a problem with the power supply? So, unplugs there. We have, so you can see primary, that's the input. So 230 volts AC, that little symbol there, and you can see it's output in DC. 3.3 volts, 2.7 amps, and 12 volts at 0.8 amps DC. So we should have two lots of oh, here you go, 3.3 volts and 12 volts. Well, this is great. They label it up for you. So we have 6 contacts here. Let's just make sure that we got the pins in here. Yeah, I mean, it all looks, that looks okay, doesn't it? They're not bent or broken or missing. Those 3 there are the negative. So that one, that one's negative. And then we've got one 12 volt and two 3.3 volts here. And I'm going to put pressure on it. Oops, hold on. I'm going to put pressure on down this way. See if anything comes up. No, well, I've got plenty of pressure on there now. So that doesn't look like it's outputting. Let's go on to that one. Yeah. So this should be 3.3. Right, so there's nothing there. So the reason the N64 is not working, there might be other faults, but I doubt it because this is an honest fault. These haven't been looked at before. They weren't purchased from eBay. They were in use and now it's just stopped working. So it looks like this here is not working. So let's take it apart and let's see if we can get, you've got to be careful now. Obviously don't copy what you see in these videos. With power supplies, it's easy to kill yourself because even though this is unplugged, there can still be big capacitors in here which will hold hundreds of volts. So I've got to make sure that they're discharged. I may have to in the video plug it in while working on it. So don't copy what you see, just take it for entertainment. Most people would not be fixing one of these. They would just be buying a replacement one because these are going to be quite easy to get hold of and quite cheap. But this is a fix it video, so it would be nice if we could actually fix it rather than just replace. Okay, so we've got some of those game bit drivers and it's the larger one out of the two. So I've unplugged, but I've still got to be careful. Well, that was nice and easy. Right, I've got to be careful what I'm touching. Now, where would the big cap? Okay, I can see a massive cap. Can you see a big cap here? A 400 volt one, just here. Right, there's no voltage in that. Right, so let's take it out. And actually, do you know what? I'm just going to make sure, because sometimes you can have conformal coating. And you need to really pierce through it. No, there's nothing in there, so that should now be safe to work on, but I'm still going to be a little bit careful. How easy is that to come out? Lovely. Right, okay. So now, what have we got going on here? Right, we've got a little fuse here. Can you see T2A, so a 2 amp fuse, 250 volts. Let's see if the fuse has popped. there's that little cylinder thing just there. No, fuse hasn't popped. It's not the fuse. So we have got the brown one going to here, so that's going to be live. There. So we haven't got a short. And neutral's there, so that's definitely okay. I wonder, is ground brought right the way through? No, ground's not brought through. Right, so we know the lead's okay now because we've got continuity between here and here. So the lead's definitely okay. So now it goes through that filter capacitor. It's got a fuse, so let's try to follow it. So it goes through the fuse up to here, through the filter capacitor, goes down. Coil, let's see if this coil is okay. So we have a coil going across here. So there's 2 prongs here and there's 2 prongs here, and there's going to be continuity between them. So again, on continuity mode, we're okay there, and we're okay there, so it's not that. Now this is going to be the bridge rectifier. This is the thing that turns the AC voltage into DC, and if you look very closely, you can see that the AC side's not going to be marked up, but the DC side is negative and positive. So, I mean, I think what I'm going to have to do, which is a bit dodgy, I think I'm going to have to plug it in and just go across here now and see if we have, for example, you know, whatever the voltage is going to be, like 300 and something volts. And then, well, I'll tell you what we could do. Maybe we could go onto diode test and see if we're getting any weird readings before we do that. So let's go here to here. Right, so nothing there, nothing there, nothing there. Swap the leads over. Something, something, and something. You know what? That's going to be okay. I'm sure that's going to be okay. Let's just see if we've got a short across the capacitor. No, we haven't. Let's just have a quick look before we plug it in. See if we can see anything that's dodgy. What's this thing here? Should we zoom in a bit more? Right, this is labelled up F. So these two must be fuses. Can you see here? It's like F202 and F201. So let's see, maybe the fuses have gone on the output. I wonder if it could be like the Xbox where the output capacitors have gone. It's possible, isn't it? Something fancy down there as well. Look at that. I don't think I've seen one of them before. Look at that. That's nice. Don't know what that is. Never seen one of them. Anyway, let's do. Let's see if we've got continuity between these ones here. Yes. And yes. Right. Okay. Is there any cold solder joints? Missing from there, but it's supposed to be. Do you know? I don't think I'm gonna be able to find out what's wrong with this one. But I think what we need to do is, I think we need to turn it over. Let's not worry about the bridge rect. Well, actually, let's do the bridge rectifier first, and then we'll turn it off, unplug it, turn it over, and then we'll measure for voltage at the capacitor. So we're going to start on AC, which is this symbol here, and let's make sure that we've definitely got AC coming to here. I can't see why we wouldn't have, because the fuse and the coil look intact. Let's plug it in and see what happens. Right, so I'm plugged in now. There's nobody else here that can touch it, so it's just me. Now it doesn't matter which way around I go. What I'm going to do is I'm just going to put these things on my leads so I don't accidentally slip and touch the probes. Right now, so we should have 240-ish volts, which we do. Right, so now let's go to DC, and we should have like 300 and something volts. Here and here. And we do 330. Right, I'm going to unplug. And the, I don't want to turn it over now, but that capacitor must be uncharging itself because it uncharged itself last time. Maybe I can turn it over by the lead. Right, so let's see now what we have here. Yeah, there you go, 47. Can you see it dropping? So we know then that that capacitor side of it is going to be working. I don't feel the need to go across that because you can see it was unplugged for about like 30 or 40 seconds, so it would have been up on 330-ish volts DC, and now it's dropping down nicely. So that all looks to be working okay. See, I understand it up to that point there, but this is where I don't understand it, because there's going to be like feedback circuits and stuff. So if you have a look up here, can you see like there's a line? So if you have a look across the board, there's like a line between the higher voltage here and the lower voltage. Can you see there's like a demarcation here between here, and it says here live circuit. That line also travels up this board here, and can you see there's opto couplers here, and they're relying on light to do feedback, so this side knows what this side is doing. I think that's what it means. So it could be a problem up here. I mean, if I can't see anything worn, apart from maybe just randomly changing the capacitors, I can't really see what I'm going to do. See, I'm thinking if the capacitors had failed, wouldn't it just struggle? Well, mind you, the feedback circuit might tell it to turn itself completely off. So maybe it is capacitor related. So it could still be capacitor related. Now, although these capacitors look absolutely perfect, there's no leakage on the board and there's no sign of bulging whatsoever, I think I am going to take each of them out, just the output ones, the 3 on the output, and put them into my ESR meter, just to see if they're reading okay. If they're reading okay, I'll put them back in. If they're not, I'll change them, just in case it could be as simple as a capacitor problem. Now, just before unsoldering them, if I unsolder them, I'm going to get a proper reading. But sometimes with these ESR meters, you can measure them in circuit and it might indicate a faulty capacitor. Annoyingly, when I do it on this one here, all 3 of them seem to be out of spec. But remember, they're in circuit. So in this next part of the video, you're going to see me actually unsolder them, so I can test each capacitor without any other components interfering with the readings. Let's go on to the right ones. It's just fallen out. Shall I take them all out? Am I going to remember where they go? Well, I suppose I've got the video to look back at. Let me see, is the board marked up? Right, if you have a look, there's a little curved line just here where the tweezers are, and that denotes the negative. They're just dropping out. You know what, they do look perfect though. Right, okay, let's first of all check the capacitance of them. So this one here, 680 microfarad. I'll be disappointed now if they're all testing okay. Oh, it's not that that's pretty close, that's 744. Okay. This one's 560. Yeah, again, that's pretty much spot on. And this one is 330. I'll check the ESR again. Yeah, oh no, slightly worried. They're all okay. Let's try it on here. Hopefully the ESR, so you know, like how much resistance they've got is going to be wrong. 680, 35. So 35, 680 is going to be, shouldn't be higher than 0.07 or 0.09 in that sort of range. Please still be high, come on. Oh no! Oh no! It's not the capacitors. No, that's alright, that's lower. Yep, that's lower. Because it's going to be 470 is 0.09, 1000 is 0.05. Oh, that's annoying. So it was in circuit, so this didn't do its job. It didn't read it properly in circuit, did it? That's irritating. No, these capacitors are fine. And this one, I suppose the fact that the capacitance reading looked to be okay was probably a bit of a sign that this was going to be more than likely okay, because they looked well out when they were in the board there. Right, 10 volt, 330, shouldn't be worse than 0.24, yeah, 0.04. Oh no, it's not them. So that is a big shame, because when these capacitors were in circuit, the ESR readings were well over the worst case limits. So I was sort of hoping that they would be faulty, but you know, looking back, if they were faulty, then you would probably still get some sort of output on it, even if it was just for a few seconds. On this one, the output is completely dead. So yeah, we've proved now that it's not the capacitors. So really now this has beaten me. There's only one more thing I can try, because I've done all the fault finding that I can do on power supplies. I appreciate there's other people out there that would be able to take it much further than me, but I don't know how you would measure the transformers and stuff, because they're working at such high frequency. I'm wondering, would an oscilloscope be quick enough to pick it up? Maybe it would be, and maybe that's what you would need to do to be able to fault find these things properly, is use an oscilloscope. If you know the answer to that, please put it down in the comments below. I know a lot of people just tend to renew the power supplies rather than work on them, because obviously they can be dangerous, and I think when one component goes, sometimes it can cascade and take out other components as well, so maybe it's not worth people's time trying to fix it. But for the video, it would be nice to prove what it is. So I'm going to get the FLIR cam on it, just in case we can see some heat spots. Maybe it can see what I can't see. And then if not, let's test the optocouplers, because maybe it's not getting the feedback circuit, because maybe the optocouplers have failed, so we can test them as well. Then if it still doesn't work, really, I'm not going to be able to fix this power supply. So I've just propped it up here, so I've got a chance to see down. It's not plugged in yet. I've got a chance to see down on this optocoupler board, because I think it's going to be something on there. But if you have a look now, you've got to be careful, because you think it's getting hot here. It's not even plugged in. That's just reflections. Yeah? You know, so only when my finger goes in, you see how much warmer my finger is. So I'm not sure whether anything's going to show up. Also, obviously, I can't prod around here to see what's getting warm, because I'll get electrocuted. Anyway, let's plug it in, see what it does. To me, it just looks completely dead. It doesn't look like anything's getting warm on anything, even that little board with the optocouplers. That's annoying. Well, let's unplug it while it's while we got this on it. Let's see if anything looks like it's getting cooler. No, so it doesn't look like it's a short off any description. What could this be? I'm really curious now. So in this part here, I used a desolder gun to actually remove this side board. This was the board that was sticking up with the optocouplers on. And I'm going to unsolder the optocouplers, because maybe there's something going on with this board where it's not communicating between like the low voltage side and the higher voltage side. So we're just popping these off here, and then we can test them with using a little resistor and putting voltage into one side, and then using a multimeter. And that way then it will prove whether the optocouplers have failed or not, because these have been known to go faulty in other products. Okay, so I looked up the spec sheet for these, and where there's a kind of line, you see it goes down, there's a kick down, that is actually the LED side. So on this one here, the LED side is actually on this side of it, not this side of it. This is where the higher voltage is, you know, like the primary side, not the secondary. So that's one thing I didn't know. I thought the LED would be on that side. And then collector emitter. So apparently what we have to do is we have to put, I've got my bench power supply set to just 0.8 of a volt. So that's on there. And this is a 300 ohm resistor. Now, is that going to fit on there, or is it all going to short? Oh, I think it's just about going to fit. Kind of need more hands. No, so maybe 0.8 of a volt is not enough to actually get the LED to work. So let's up it to 1.5, and we'll do the same again. So now we've got 1.5 volts. Here we go. So it's doing something now, isn't it? Right, let's go the other way. Whoops. Never used that feature before. Yeah. Right, so 3.2 thousand ohms, yeah? 3,200 ohms. Now, let's up it to 2 volts. And let's see if that changes. Yeah, it's only 660 ohms now. So let's up it to 2.5, and that should be even lower now, shouldn't it? So what do you reckon, 300 ohms? 500 ohms. So that says to me, let's go all the way to 3 volts. That says to me that this optocoupler is working. And now we're at 409 ohms. So yeah, that's I'm pretty sure that that optocoupler is working. Let's do the same on this little one down here now. It's doing something. You know, the reading's changing when we go across it. So you know what? Those optocouplers are absolutely fine. Right, so this one here has beaten me. I've tested the capacitors, they're okay. I've tested the optocouplers, they're okay. And I've tested the input side of things all the way up to the capacitor, and they're okay. I can see no burning on the board. I can see no damage of any components. So I can't take it any further. I should just get myself another one and finish up the video, as I can't find out what's wrong with it. But I've been looking online, and there's quite a few people that do have problems with the N64 power supply. Some of them fix it by just changing out the caps because the output is too low. But then there's others that can't find what the problem is. There hasn't been a successful outcome. So I thought to myself, okay, come on, don't just give up. Get another power supply. But they're a little bit more expensive than I thought. And if you want the proper Nintendo ones, you can get like aftermarket ones for between £15 and £20. But the Nintendo ones seem to go from £20 to £30. But I don't mind, you know, I'll spend money on a video happily if it makes the video more interesting. But I've seen that you can get Japanese ones for about, I think I paid about £6 or £7. And what I thought is, before I uncover it, I thought that the output might be the same. I know the input's going to be only 100 volts or whatever it is, but I thought the output side of it might be the same with that optocoupler board, because that's what I want to do. I want to swap over the optocoupler board, and if everything starts working, I know then that the fault's on that little board, and I can just start swapping components until I find the faulty component. If it doesn't work, I know the fault is on the board, not the optocoupler board, but I need a working one to be able to swap stuff around, because there's too many components to fault find. So I bought this, and it's completely different. I thought, oh, that's a bit annoying. I thought, well, okay, rather than spending, again, between £20 and £30, I'll get another Japanese one and see if I might strike more luck on that one. And this one here is stuck down, but I don't even need to undo it because I can't see the solder joints that are on this one here, you know, the whole row on that optocoupler board. And what's annoying is, have a look. Even this is completely different to this. Look, that hasn't got a big chip here. The boards are different. You see, we've got chips down here. So even these two here are different boards. So I thought, okay, don't get any more Japanese ones. Let's get a UK one. So that's what I did. I bought a UK one, 20-ish, 20-something pounds. It came through, opened it up, gutted. It's completely different than the board I'm working on. We've got a small little board here, and yeah, it doesn't resemble the one that I'm working on. So I thought, well, that's irritating. But now I'm in deep now, you know what I mean? This is the third power supply I've bought, so I'm in deep. So like a gambler, I've got to get an outcome to this. So I went and bought another one. And can you believe it, when I opened it up, it's different again. It doesn't even resemble this one. It doesn't resemble this one or this one. And you might think, well, that's stupid, Vince. Why are you doing that? Because the model numbers are all the same. D63760. 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 So we've got 3 power supplies here with the same model number, and all 3 are completely different. So right now I'm in deep, you know, because this is now 4 power supplies I've bought. And I thought to myself, give up, Vince, you know, like I know what gambling feels like, and just you need to give up. And I thought, oh, just one more, and then this arrived. I plugged it in, it's all working, I've got the correct voltage here. I opened it up, and now I thought, you know what, it's going to be different. I knew it was going to be different. But then when I opened it up, I seen that lovely sight of all of these solder joints in a line. And then when you open it up, I can see an optocoupler board. So fantastic, I've now got something. I'm so glad I didn't give up, but it took 5 power supplies in order to get this one. So that's it. What I'm going to do is I'm going to unsolder this board here, and then we're going to pop it in here and see what it starts to do. Now, I have chopped a few bits out of this video because when I first of all got the Japanese ones and one of these, then I thought to myself, let's do some more testing on this. And what I did is, I'm going to show you now, I had that board unsoldered with the opto couplers. That board was off. And I thought, I wonder what would happen if you plugged it in with this board off. Would you suddenly get like voltage on this bit here because this board isn't telling it? I know you wouldn't get voltage over here, but I thought that this board isn't going to tell it not to do something this side. So I thought I may be able to fault find it further into the circuit. And when I went to plug it in without this board, this is what happens. Look, I am going to plug it in. Let's just see if it goes bang. Right, so obviously don't copy what you see in my videos. I've got my face away from it. Okay. Whoa, okay. Whoa, look at that. Well, that's going to make a nice thumbnail. Oh, wow, look at that. That really went bang. That really, but you know what? I didn't think that was going to happen. So that was, what was that? Oh, this capacitor here. That capacitor here went bang. Look at that. That's some, this smoke is still going here. Oh, lovely smell. Do you know what that smells like? Party poppers. Do you remember when you were young? Pulled a party popper, sniff the inside. Yeah, look at all that there. Oh, that's annoying. So as you can see there, that was one hell of a bang. Luckily, I had it that way there because that cap would have exploded upwards. I, in my mind, thought that by removing that, it would be the same as it not working. But no, it's not. I mean, by me showing that to people now, some of you are now going to know what's wrong with this. Because in a way, maybe the feedback side of it's working and maybe it's a problem with these chips here. But in my mind, I still don't know why that happens because I know this is going to be some sort of transformer thing. So I presume it just put all the high voltage straight through into this cap here. Now, I have put a cap in here, but it's the wrong rating. I've ordered up 5 of them, Panasonic ones from eBay, and it's been about 11 days now and they still haven't arrived. So this is what I'm going to do. I'm going to unsolder this board and I'm going to unsolder this cap. I'm going to put them into here. If it starts working, fantastic. We know it's not going to be the cap. We know it's something on this board. Let's get going now and hopefully we can get something, a more concrete answer to what's causing this problem. And I've also bought some second-hand fuse covers off eBay as well, so if I can get it working, I can make that safe again and put a different fuse in there. So I'm just fast forwarding through all this now because I need to quicken up the video a bit. So you can see I'm just using the desolder station here to take out the boards, swap them over, and I'm also going to swap over the caps as well. And we'll see whether the fault follows the board. If it does, yippee! It means then that we can fault find the board and there's less to fault find then rather than trying to go across the whole thing. So anyway, let's give a shout out to the My Mate Vince Massive. And the members this month are kitsdigital.com, Kip Hakes, Max Rokotansky, Having Fun Repairs, Will Michaelis, Chris Seal, Felipe at MrKeeves.com, DJVG, Pigsy, Robert from Timsy's Auto Air, Daniel Watson, Zeke C, Anthony Dean, Bazza2, Operational 117, Russ Mellinson, Save Our Stuff, and Ellis Garbutt. Thank you so much, guys. Now we are ready to turn these both on and let's see what's going to happen. Exciting times. I think we should start with this one. So this is the one with the suspected bad opto coupler board. Now, hopefully it doesn't go bang, but if it does go bang, it's not going to explode past here. So here goes, I'm plugging it in now. Hasn't gone bang. I'll leave it just a few more seconds. Let's see if anything is happening. I'm wondering, I don't know, I think I'd have more chance of fixing it if this was working, because I think if the fault's on the opto coupler board, it's going to be harder to fix. Here goes. So, where are we again? Negative. Let's see if anything's coming out. No, there's nothing there. There's nothing there. I bet you it's the opto coupler board. Nothing there. Right, okay. Let's unplug that one. And now let's do Rob's one, which now has the known good optocoupler board in. Again, please don't explode. Plugging it in now. Good, nothing's gone bang. Still nothing gone bang. Right, let's test it. Imagine if it didn't work either. Come on now. Give me 12 volts. Yes. Fantastic. 11.2, that's fine. Some of mine are only outputting 10. And they still seem to work on the N64. 3.6 supposed to be 3.3, is it? 3.3, okay. So one's slightly higher, one's slightly lower. Anyway, look at that. So there we go, we've proved it. It's the optocoupler board. Let's unsolder again the optocoupler boards and let's just go across with like resistance and stuff, see if we can see a difference between the two. Now this is where the fun begins. So the bad one is up top. Right, I reckon that this is the ground because you can hear it coming up on the caps here. Right, so let's keep it on ground here. So none of that's going to ground. Oh yeah, that's going to ground. But nowhere else. Right, so that looks normal. So you get the idea. I'm just going to go across everything to see if I can find anything that's different. Right, as far as I can see, these are both reading the same on this side of the board here. So there's no difference in that chip, transistor, and when I go across the components, there's no short. So now I'm going to go over here. I mean, I haven't gone across every single diode and stuff, but I want to get a reading now on this one here. So it looks like the last pin here is ground. So on this bit here, I'm using diode test on my meter, the same way that you would measure a diode. And I'm putting red lead to ground and I'm probing with the black lead. And I'm doing it on both boards to see if the readings on my meter are different from each other. Now the reason I know the last pin is ground is because I've actually looked at the main board and I can see that it's ground on that one. For example, I can see that it will go to the negative of a capacitor on the output side of this power supply, so I know that that last pin is ground. So yeah, that's what I'm doing here. I'm just going across all the components, starting with the chips and stuff, to see whether there's any difference in readings. Oh, I found a difference, guys. Right, look. I'm not sure if it's relevant or not. But you see this tiny little chip up in the corner here. Well, if I go to red probe on ground here, and if I go to the top right pin, it's 1.63. Middle pin, 1.82. Bottom pin, 0.33. Now look at this one here. Right, so that's very similar, 1.72. 1.81 similar, but 1.72. Can you see here the difference? 0.33. So let's check this side here, top left. 0.33 again. Top left, 1.72. That's a big difference. Interesting. Right, so the good one is reading different than the bad one. Wow. Right, let's zoom in and have a look at that top chip, see if we can see any damage on it. Interestingly, that's the kind of chip which is covered in all this gunk. There's all this gunk up here, and also gunk here as well. Imagine if it was something like that became conductive over the years. Obviously it's not that, but let me just see. Nah, it's not getting any reading on it. I'll tell you what, let's do it under the microscope. Oh man, I really know how to spoil a video that has potential to be okay to watch. I was recording on the microscope for about 15 minutes or so, showing you around the chip. And I just turned the microscope off rather than pressing stop on the recording. And then I thought, oh, I hope I haven't like damaged the ability to record. So I turned the microscope back on, pressed record, seen that it was recording, turned it off. Just went now to get the footage from the microscope while I'm editing, and I only have footage for 1 second. The 15 or 20 minutes that I recorded previous to that is not there because I turned the microscope off at the switch rather than press stop recording. And so now I've just put it through data recovery, you know, that disk drill or whatever it is, and it's picked up everything that I've deleted off that SD card, but there's no evidence of this footage here. But you know what? It isn't the end of the world. Let me just explain what's going on while you look at the top of this microscope. So, next to that chip, you've seen that there's 2 legs on that chip that are reading different. Well, those 2 legs are connected together, and from there it goes to a resistor next to it. That resistor is under a load of that gunk. There's still gunk left on the board. That resistor has got a 221 on it, which means 220 ohms. And it's not measuring anything. It's completely open. I've never had a fault, I don't think, with an open resistor. So basically, the resistor under the gunk has gone open. That then goes down to the ground pin, you know, the last pin on that board. So basically, the chip is not getting ground. So that's what I was showing in the microscope bit. Now let me just show you to the end of that bit there, where I'm just doing a little bit more testing on the resistor. It's just weird that it was underneath this gunk here, as if it's just a bit of a coincidence. Could it be something to do with that gunk? Or is it because this thing's generating so much heat and the resistor is kind of underneath this, so that the resistor's overheating because it's got all this blob stuff covering. You see here as well. You know, the blob stuff's covering it, isn't it? Right, so ground from here to that top leg, this is the good board, is going to be 200.22, yeah? And to this leg here is also going to be 0.22. So 220 ohms, because that's what the resistor is. Now, on the bad board, so we're in the megohms because the resistor, there isn't actually any path because the resistor's not working. That is unbelievable. Right, okay. Let me see if I've got one of those resistors. We'll pop it in. Imagine if it started to work. Okay, I've gone through my bag of little SMD resistors, and these look to be exactly the same size, and I found one which is 220R, and when I look through my eye loop, it says 221 on them. So let's pop one of those out. I think it's to do with overheating, because it's been covered up for so long, and resistors get rid of their energy by heat, don't they? Right, I won't measure it out of circuit because it's absolutely tiny, but when it's in circuit I'll measure it then. Right, let's zoom right in. I think I'm just going to use the soldering iron to remove this one. Right, hopefully if I just go either side it might heat up enough. There we go. Now let's see if I can put the new one on. Again with the soldering iron. Right, there we go. So that's in its home now. So let's zoom out and see if we've got nice resistance now going across there. So we should have 220 ohms. I'm just going to clean up this one here. We're on diode test. If we go to ground with the red lead, and if we go to the top left pin, you can now see 0.33, and bottom right pin 0.33, and on this one, top left 0.33, bottom right 0.33. Yeah, and that's the good one. So it's reading the same good and bad. I just want to do a resistance test just to make sure. So now from there to there we have got, on the good one, so 224 ohms. And on the bad one, 222. Fantastic, so that's great. And I just want to check the middle pin here. Next pin along. So yeah, 1.5K, so 1500 ohms. 1500 ohms. Right. I am going to solder this back into here, and let's see now if it starts working. I've got my hopes up. So we're going to put the original faulty board back into Rob's power supply here. Okay, I've had a look closely from my eye loop, all the joints are fine and there's no shorting in between any of the pins. Now I'm just wondering, why did they put this blob of weird glue stuff up here? And I'm thinking, is it to stop this wobbling about? You know, with the shock of this getting knocked around the place. Look, it is quite top heavy, isn't it? So what I'm going to do is I'm just going to get a tiny little bit of hot glue, and I'm just going to put it in the back here, because there's no components on the back. This is a one-sided board, and then that will stick it to here, and I'll do the same on this one here. So there you go, I'm going to put that in there, and that will now drip down in there. And hopefully that will act the same as that weird glue stuff, but yet it won't be covering up the resistor. And I'm going to swap this out for a 3-amp fuse. Okay, so I've got a 3-amp fuse in here now, and I've put a new cover on to make that nice and safe. So let's pop this back in, and we'll see if it's going to work. Here goes. I'll tell you what, before we do that one, let's plug in the other one. This is the one with the bad, I'm looking away. Hasn't banged, good. This is the one with the underrated capacitor. So basically everything in here is now original to Rob's one, apart from I had to change the capacitor out from this one, because obviously I sent hundreds of volts into the 25 volt cap. Right, so this here should still be working. Excellent, 11 volts. And 3.5, fantastic. Right, so we haven't made that one worse. When the proper cap arrives, which still hasn't, I'll pop that in there, and then that will be a full-on working power supply like it always was. Now, Rob's one, here we go. I haven't put the screws in, but apart from that, it's back together. Ooh, slightly nervous. Right, I'm gonna turn away. I'm plugging it in now. Excellent, hasn't gone bang, fizzle, or popped. Now, is it gonna work? Come on. I've spent so much time on this. I've actually slightly got the shakes. Come on, let's see this move. Come on, come on, come on. Yes. Yes! Oh my God! What? 11 volts. Oh my God, the hard work paid off. Come on. Oh wow. 3.5 volts and 11 volts. Yes, amazing. All because of a tiny little resistor. I don't think I've had a resistor fail before, but look how small that is. It's absolutely tiny. You can't even see. You can just see it looks like a bit of dirt. It's not. That is the resistor. That wouldn't have even cost 1 pence. You know, the whole resistor kit here from China would have probably cost £10 or something like that. And it's got hundreds, if not thousands of resistors in it. That wouldn't have even cost 1 penny. Obviously, I had to spend £100 of Nintendo 64 power supplies to get to this stage, but learning was done along the way. So there we have it. It must be that gloopy stuff covered over the resistor. That gets rid of its energy via heat, and I suppose the heat couldn't escape. And if it's been on for hours on end, maybe it just got so hot it burnt itself out. I don't know. Put down in the comments below what you think. I wonder, is that a common failure? Ah, that is amazing. I'm so happy with that. Let's just double check now, because it's been on for a minute or so. Ah, how good is that? I'm so pleased. There you go. Right, okay. I'm going to pop the screws back in it, and then yeah, connect it up and just show you it working at the working on the TV. Oh, I'm so happy. There you go. So you can see the red light on, and we've got the game up here. 1080 snowboarding. Right, let's do a quick game. Oh, feels quite nice. Oh yeah, I like that. Don't like that. Let's just see if I can do one jump. Oh, I didn't even see that coming. Oh, on the head. Can I jump off that? Yeah. There we go. Right, well there we have it. Results. So, all because of a tiny little resistor. So it shows you in this instance here, perseverance pays off. I mean, it is a shame that I didn't get lucky on the very first one I bought. I had to buy 5 of them before I got one with the same board on the inside. But personally, I wouldn't have been able to fault find it any other way. Other people would have done, because if you would suspect it was that top board, which I kind of did, then really I should have gone across every single component, and I would have seen that this resistor had nothing through it. It's just that I haven't come across a resistor fail before, to my knowledge. I don't think so anyway. Maybe there is a fix somewhere that I did, but normally it's a capacitor, isn't it, that they go short, or some other component, but not a resistor. So it was interesting to see that that resistor went open. So that is it for this video. If you enjoyed it, give it a massive thumbs up, and I will see you all very soon. Thank you so much for watching.